All right, today we're going to be taking a look at transfer switches. More specifically, what are they, what do they do, and do you need one? Now, as you can see here, I have several different types on the bench, and this is not even the half of it. There are a ton of different transfer switches. They can function differently, they look different, they perform different tasks for different things. And there's different terminology, like in the commercial and industrial side, things like make before break, that get really confusing really quickly. And these are all engineered specifically for their solution. So we have to narrow the focus here. Most of the stuff we're going to be talking about today is going to be residential, things that you would use in your house for backup power of either your whole home or a specific item, your refrigerator, lighting, a sump pump, heaters, things like that. So what exactly is a transfer switch? Well, a transfer switch is something that, as the name implies, transfers from one source of power to another and sends that to the load. So say something like a lamp, for instance, as the load, and then you have it plugged into the wall as a source. A transfer switch would allow you to switch between the wall power and a secondary source of power like a generator or a battery backup. Now, these come in two fundamentally main types. Those are automatic and manual. And as you would think, the automatic will automatically transfer if the power goes out to the primary, and the manual is going to be switched by the user when they see that they need a different power source. So, with automatic and manual out of the way, we can delve into the rest of the different types. Now, there are service entrance style transfer switches. Those will go between your meter, essentially, and your main electrical panel. So anything that's on your main electric panel for your house is going to be switched with that transfer switch. This is great if you've got something like a large generator, or if you just want to have the ability to put anything essentially in your house on your generator or backup power source at any time, pretty much for any reason. Now, there's a ton of different types of these and different installs, so we won't really get into that. But usually these are something like the automatic transfer switches for the automatic standby generators. And you'll see those where they're a box on the outside of the house that the electric main feed runs from the meter into them, and then from them into the house. And then they will have a secondary power source that's usually permanently connected to a standby generator. There are also manual transfer switches that you can get that function the same way. They switch your entire electrical feed. And there are some pretty neat, like meter socket transfer switches that are for smaller generators. And these are manual. They go basically between the actual meter and the meter socket on the meter box outside your house. And this would be something that would be installed usually by like the electric company, because they have to pull the meter and shut everything off to do it. And they allow you to connect into the side with your portable generator. So if the power goes out, you can feed in that way with minimal installation. Now, with some of these transfer switches that we're going to be covering and some of the different ways of transferring power, know that they are not always allowed in every utility and every region with every electric company. It would be something that needs to be covered by codes enforcement or with your utility as to what is and is not allowed. So kind of take that as a warning. If you're unsure, that is something that you would need to figure out. Maybe speak with a licensed electrician, or ask your licensed electrician to install it if you are not comfortable with a lot of this. Some of them get very advanced. Things like plugging in something to a wall outlet is, of course, something that pretty much anyone can do. When you start getting into the utility side, that really needs to be handled by a professional, because it's a lot of power and it's not always able to be turned off for the working. Now, transfer switches can be as simple or as complicated, basically, as you could ever think of. It could be something as simple as a three-way light switch that has one power source coming in and then another one on the other side with the common out to your load. This is done sometimes for like the 120 volt power source for certain types of furnaces and things, or sump pumps if you want to switch them to a backup power source. The big problem with something like this is that for installation, at least in North America, items are required to be listed for their use, and a light switch is generally not listed to switch two different sources of power to one common load. They're really for the same source of power from two different locations. So if it's not listed for it, technically you cannot use it for that. Now, there are specific switches that have been listed for this, and they usually, unfortunately, have the price tag to match. But there are single point-of-use manual transfer switches. Usually they're like a 15 amp circuit that have a power inlet on them for like an extension cord, and then a hardwired input, hardwired output, so that you can connect your furnace or your sump pump to them permanently, and then if you need to, you can plug in a power source to them and switch it over. These are all manual styles of transfer switch. Now, for larger loads, you start running into things like critical load panels. This will either be a transfer switch that is between your main panel and a sub panel and will switch the entire sub panel over, or what is more common is you see a sub panel that actually has individual circuit transfer switches inside it, so the breakers stay in the main panel and it will go over to a separate panel feed with each individual circuit on it. These are usually things like 6-circuit or 10-circuit transfer switches. So you would pick the most commonly used or most need-based sources in your house and put those on this panel to switch in the event of a power failure. And you can get these in automatic or manual. More recently, you have started to see a lot of what are known as like smart panels or smart transfer switches coming out from manufacturers of alternative power sources, battery backups, solar power sources, and whole home battery, things like that. EcoFlow, Anchor, a lot of those have their own smart panels, and they tie into their system and are able to automatically transfer over to their battery. Simultaneously, they're able to charge their batteries. They can have power going out when the grid is on to charge the battery up, and they can communicate with it to know when the power goes out. They can communicate with the battery to turn on the loads that you have put on this panel. Now, the major issue with these is that they are pretty much primarily for use with the systems that they were designed for and by the company that made them. So in the future, if you want to go with a different battery system, or you wanted to use a generator or something, a lot of times there's no real way to connect into these to power your house through them other than the methods that the manufacturer has provided. So if it's designed to be connected to their battery systems and their battery systems only, you can't use one if you don't have their batteries. So this can be kind of a problem if you really like their transfer switch and want to use it, but you say want to use a generator rather than batteries or something. This can get really, really complicated and is generally more of a proprietary thing. Now, there are some companies like APC, which manufactured these two items right here, that have non-proprietary systems. This is a UTS, a universal transfer switch from APC, and it's actually been around for probably like 15 years now or so, and it does a bunch of really neat things. This is a 6 circuit. They also have a 10 circuit, and they have 120 volt and 240 volt models. So this is essentially the older equivalent of one of those smart panels, except that it is universal. It works with any power source that you want to connect to it. These, again, as I say, have been around for a while. They used to actually be kind of the listed thing for transfer switches with the Honda inverter generators and stuff. It was in their catalogs and things for them because they were sold a lot of times to people wanting to connect their inverter generators into their whole house with specific loads. So the really neat thing with this is that it is computerized, and it can take 3 different power sources with some caveats to that. Now, this one right here is a 6 circuit with a 30 amp generator input, and it is only 120 volts. So it connects in to your main panel. It actually connects to both legs of your main panel on the split phase, and that is solely so it can monitor to make sure both are out and it's not just a breaker tripping somewhere or something. So it does have some requirements for that, for receiving 2 power legs in before it will switch. The generator input is a 30 amp. You can get them in hardwired, or you can get them in a twist lock, which goes in the blank right here because this is the hardwired, in which case it just connects in with a cable on the front of the unit. This is meant to be used indoors only, and it can be mounted in a wall or on a wall. And then it has a lead out with all of the circuits that go into your panel, because this connects between the circuit breakers in your panel and the circuits of your house. It does have fuses in it to protect. It is kind of an older way of doing things that a lot of people have questioned because it's not resettable. If one of those fuses blows, then you have to replace the fuse. You have to take the cover off and swap them out because they're not circuit breakers. That is the major downside to this. But if you blow that fuse, there was probably a reason for it. Realistically, the circuit breaker should trip first if everything is set up properly, but it does happen, and you'd want to keep a few spare fuses handy, just like the old electrical panels. Now, the computerization of this is really cool because it knows the load on each of the circuits going through it, and you can set priorities and do load shedding. So this can have different time values and things like that set up. So you can actually connect 6 circuits onto a smaller generator, and you tell it what size the generator is and how much the power output is, and the priority of certain circuits. Like, hey, turn the lights on when the power is off and we're on generator, and their priority number 1, keep the lights on. And then the microwave could be like a priority number 3 or something, and then have another, like the refrigerator, be priority number 2. And what that does is, if you don't have enough power to run the refrigerator and the microwave at the same time, when the microwave turns on, it will actually momentarily turn power off to like your refrigerator and allow you to use the microwave. And then when the microwave's done, it'll wait a little bit and then turn back on the power to the refrigerator, since the refrigerator's gonna stay cool in that like 3 minutes that you're using the microwave without a problem. You can turn all of this on and off. It is not something you have to do. It's just a really neat feature, and it makes sure that you don't accidentally overload your generator. And this is fully automatic. There is a connection on here for a UPS, an uninterruptible power supply. It is limited, I believe, to like 12 amps. And this can go connect to any of the circuits on here. You can select them to run off of that all of the time. And it has a little convenience outlet that you plug into that. This is something that is recommended because if the generator is not on yet and the power is out, this doesn't work. It has no power. So if you plug a UPS into it, it will actually remain powered and be able to perform its functions and power up at a faster rate. Also, if you've got a circuit like, say, your home office, and you want to make sure that your home office doesn't turn off during a work call, you can set that to the UPS, and as long as you don't exceed that like 12 amps of power, you can basically take the entire circuit for that room, depending on how your house is wired. You can take the entire circuit for that and run it off of the UPS so that in the event of a power outage, that room, the lights, your computer, and all of your stuff stay online. So you're not in the middle of a work call and all of a sudden go dark and everything shuts off. So that is a really neat feature. Same thing if you've got sump pumps. If the power goes out and you rely on a sump pump to keep your basement from flooding, you probably want that to stay online. So maybe you even have a generator that you can use, but you might not be home, or what do you do in the time it takes to get that generator out? That's a good feature for making sure that that circuit stays online and running until you can connect another power source and power it up. This does have a output for automatically starting a generator. It is not super well documented. It's a little bit more on the experienced installer kind of use case. But depending on what you have, if you have a generator that can automatically start, either an installed one or a generator that has an input for turning it on and off remotely, and you, again, want to make sure that is somewhere safe, not in your garage, so it starts up and asphyxiates everyone. But this can actually output the signal so that when the power goes out, it can send the signal to start the generator up automatically and, again, handle all of that. It also has a nice little screen on it that lets you see the information on what loads are currently on and what they are consuming. Good place to insert. APC did not sponsor this. No one sponsored this. These are all my personal units. In fact, this one is getting ready to be installed in the house for specific loads. I do have a whole home transfer switch or an interlock, but for smaller loads, I want to automatically switch over to a battery backup in the event that I'm not home, or if I'm, again, in the middle of a work call or something and need to have it automatically switch over. Good place to transition to interlocks. Interlocks are not transfer switches. They, in most people's minds, perform the same function. They allow you to basically turn off the main breaker of your panel and turn on a feed-in, and it's kind of like back-feeding your panel in through a breaker and distributing the electricity out. This is not allowed in quite a few municipalities, codes enforcements, electric utilities. A lot of them do not allow it because if the cover is missing off the electric panel or there is an issue with something, theoretically it could accidentally allow power to come on both sources, which would be very, very bad. That's kind of at best, it would fry your generator. At worst, it would fry someone. So not everyone allows these, but if they are allowed, they can be a good, very cheap solution to getting a generator connected into your main panel. Again, they basically just allow you to send power into your panel so that every one of those circuits that's on there is energized. It's kind of the equivalent of like a poor man's utility transfer switch or service entrance transfer switch. Now, the main benefit to a service entrance transfer switch or an interlock is that it's going to connect everything in your panel. This means that if you have something like a whole home surge protector, that whole home surge protector is actually going to work the same way on your generator. So your generator also would have the benefit of the whole home surge protector for the loads. So if you do get minor surges and things coming in from your generator power, theoretically, that could help with that to keep it from harming loads and things in the house. So that is a big kind of selling point for doing things like that compared to a critical loads panel or something, or a separate circuit transfer switch, because those transfer switches are usually not going to connect into that. Unless you have one that allows you to put separate breakers in it and you, for some reason, put a surge protector in there, for the most part, that means you're going to lose your whole home surge protector when you're running on generator power, which some people may want that little bit of extra protection for certain things. If you hear a little bit of rain noise and wind, I'm actually in the middle of a tropical storm right now. Now, another type is going to be the point of use type. So you're going to have something along the lines of this rack mount enclosure. These are used in data centers and IT installations for companies and things, for servers. And then you're going to have the point of use transfer switches in UPSs and in things like these battery backups, if the manufacturer offers them. This unit is really neat because its transfer time is somewhere between like 4 and 10 milliseconds, which is basically uninterruptible. At that point, the capacitors and power supplies and things pretty much are able to maintain the voltage. So it can take over the load and transfer it before you would even know that the power went out. These were previously, like when new, they can be fairly expensive. They can be hundreds, if not thousands of dollars because of what they are used for, and their reliability ratings and things, their mean time between failure. Now, you can get these on sites like eBay for usually around $100 or so, and that starts to make them a lot more reasonable depending on what you're using them for and what your use case and everything is, how critical it is. So the neat thing with these is that they just plug in. There's 15 amp, 20 amp, 30 amp, 120, 240. So you do need to be very careful about which one you select and kind of research and know your model numbers. In this case, this is a 20 amp. And it had twist lock connectors on them, which you're really not going to find in any residence. But that was a simple changeover with different connectors on here to allow it to run on a regular wall outlet. And this just has 2 plugs and then 1 output plug. So whatever I connect into here switches between these 2. And again, it is automatic. You set the priority and the sensitivity on here, and it will stay on the priority 1 output unless it goes away, and then it instantaneously essentially switches over to your backup load. So if you've got a battery backup or something, this can be great for computers in your house, keeping your internet up, things like that. Or again, if you want to automatically transfer a sump pump over to a backup power source. So these can be a fairly cheap entry into a very high-end system. If you've got like power inlets for circuits in your house that allow you to plug a circuit in your house essentially into a power cord, like a portable power cord. You could actually put essentially an entire circuit on this as well. You again just want to check and make sure that's code compliant, or that you live off grid somewhere that you don't care. Not recommending this. Proceed at your own risk. The other type is going to be built into devices that a lot of people don't even realize have them built in. So something like this EcoFlow power station has a transfer switch built in. I think it's around 30 milliseconds. So very sensitive electronics may cut off and come back on. But for the most part, things like computers and stuff actually can stay online with this. Essentially, with some of these models, some of the Anchor ones, and I think even the new like DJI ones, they connect into power like you would plug them into the wall outlet to charge them, and then you plug your load into them, and basically they're kind of like a standby UPS, and they're running off of the power from the wall until it goes away, and then you'll hear a couple relays click and they connect into the battery. This way, it is not always running on the battery, so this is not like an online or a double conversion UPS. You're not powering the battery and then the battery is powering the device. It is bypassed. But if you've already got one of these, it can be a really good use case for putting between like a generator. Now, generally an inverter generator would be required for a lot of this. A lot of times these do not like the power output from some of the like smaller standard generators. They can be picky about it and say that the power isn't good and they won't actually start up from it. But if you've got computers, or if you are worried about the power going out and are in the middle of an online test or a major work call or something, and you want to make sure that your power stays on and you don't have a UPS on your system, you can actually use one of these in between and it will automatically transfer over to the battery. This is kind of a pseudo transfer switch because it is only between the power coming in and the built-in battery. It does not allow you to select between sources like something like one of these external transfer switches does. So this is not going to select for you between a generator and a wall outlet or something. It is only the battery that is built in. And once the battery in it is like runs dead, you run out of power or whatever, you have to charge it back up. It's not gonna, just keep running forever. It is the battery in here. So it is more like a standby UPS than a transfer switch, but it is technically a transfer switch internally. So, again, there's a million different kinds of transfer switches, and I'm sure that I have forgotten a ton of them. Solar inverters a lot of times will have transfer switches built into them. A lot of the Victron equipment and things does and can actually switch between the inverter battery backup and a generator input, a primary power input, usually known as like shore power or generator power. So a lot of times people in boats, RVs, things like that, they already have transfer switches. There are also RV transfer switches that are made essentially the same way as this one, that take an incoming power circuit, and when you connect into shore power, transfer over to that off of the onboard power that you're using from your alternator battery system, leisure batteries, things like that. So this is a huge world of things that allow you to connect in emergency power sources and convenience things. If you know of something that I missed, forgot about, whatever, post it down in the comments section below. I'd love to know about it, because maybe it's even something that I hadn't heard of before. And it helps everyone else if there is something that I missed, so that they can look it up themselves. Now, why would you want to use one of these? Well, if you don't want to run extension cords all over your house in the event of a power outage to connect to a generator and unplug everything and plug it in and then plug it back into things when the power comes back on, you'd want a transfer switch in whatever capacity, whole home, sub panel, or point of use. Or if you want something to be automatic, then you have to have an automatic transfer switch. So if you've got something that's critical, like your sump pump, or if you want your furnace, ignition and things to stay on, your blower, pellet stoves with forced air, things like that, it can be a really great way of taking one less thing out of the equation when the power does go out. For me, I have a bathroom that does not have any windows in it. And so if the power goes out, even during the day, you could be standing in the shower, in the complete dark, and not even be able to see to move around to get out or anything. Things like that can be dangerous. So sometimes an automatic transfer switch on that circuit, even with just a battery backup for 20, 30 minutes, it could be the difference between keeping the lights on and getting dried off and everything, or kind of fumbling your way around in the dark. So hopefully this video has helped people out there. Again, if you know of anything I missed, leave it down in the comments section below, and I will see you guys in the next one.